And last but not least, we have question 3. The scatter plot below shows the relationship between the ticket price compared to the row number at a concert. Once again, we can see ticket prices on the y-axis, row number is on the x-axis. So the equation of the line of best fit that models the data is y hat equals negative 2x plus 80. What is the slope of the line? Interpret the meaning of the slope in the context of the problem. So what is the slope? The slope is the number in front of the x, so negative 2. And if we interpret that meaning, then we can expect that the price is going to go down about $2 for every row. So we'll expect a decrease of $2 since it's negative. For every row, for every one row, or for every row. What is the y-intercept of the line of best fit? Interpret the meaning of the y-intercept in context of the problem. So the y-intercept is the number after the x, so the 80. And that's going to be that we expect $80 if we're in row 0, meaning if we're in the front row, that ticket's going to cost us $80. So we can expect $80 for front row seats, or for row 0 seats if we want to. And last question, use the equation of your line of best fit to predict the cost of a ticket in row 17. Now we can look at our graph for row 17, but it's really hard to know exactly where row 17 is and to know exactly that dollar amount. So we're better off plugging it into our equation. So we have our equation, y hat equals negative 2x plus 80. We know row number is my x-axis, so all I have to do is plug it in for x. When we plug that in for x, what do you get for y? In other words, how much is that ticket going to cost? Okay, so we can do negative 2 times 17. We get negative 34 plus 80. And negative 34 plus 80 is going to equal a total of $46 for row 17. And if we look at our graph, approximately row 17 would be right about here. And we look at our line of best fit, boom, right close to 46.